Alright, we are proving lines parallel, lesson 5.02, exit ticket. Let's review what we talked about in 5.01 with transversals and parallel lines. You want to recognize the different types of angles and the angle relationships that we can have. For example, we can look at the figure that has a transversal, which can be named with any letter that you wish, lowercase script letter. Letter T would be a good letter for that, and then you could use letter M and letter N for those lines. And M and N we usually define as being parallel. However, as long as the line T crosses those lines, it doesn't matter if M and N are parallel. However, we're going to allow them to be parallel because that condition is necessary to reference the postulates and theorems that we're going to reference today. And when that transversal intersects those lines, it creates a set of groups. And in those groups, we have certain angle relationships. So I'm going to go ahead and point those out now. We're going to start by looking at the exterior angles. We have angle 1 and 2, 7 and 8. They are on the outside or in the region outside of and not between the two lines M and N, so they're exterior. Then we have our interior angles as well in between the two lines, so 3, 4, 5, and 6. Then we start to get to the actual angle relationships. And with that being said, we can see that we have the consecutive interior, so 3 and 5 on the same side of the transversal and inside of the figure, the interior. 4 and 6 are in the interior and on the same side as well. You have the alternate exterior angles, which is 1 and 8, and we have 2 and 7. We also have the alternate interior angles, 3 and 6, and 4 and 5. And then lastly, we have the corresponding angles. So we have angle 1 and 5. We have angle 2 and 6. 4 and 8. 3 and 7. And those are the corresponding angles. In reference to the angles that I just mentioned as well, we want to also keep in mind that for same side interior angles, they are going to end up being supplementary. So their sum is equal to 180, whereas these remaining angles here are going to end up being congruent to each other, and we'll reference that more clearly in the slides to come. So we're going to talk about the converse theorems. To start that off, we need to address what a conditional statement is. As a reminder, this is something we've already covered, but a conditional statement can be written in symbolic notation using P and Q. And what that represents, and sometimes it can be written this way, if P then Q, is you have a hypothesis and then you have a conclusion, right? So P is going to represent your hypothesis and Q is going to represent your conclusion. Okay, so having the hypothesis available is the condition that you're establishing is given, and the conclusion is the result of that given condition. That's why they're called conditional statements. Now I bring that up because I've written down 4 conditional statements at the very bottom that you can see there. And what those actually are the actual postulate or theorem of each of those types of angles that we refer to. So I want you to pay attention to something here. All of these right here that we have outlined represent the original postulate or theorem, and I want you to pay attention to the conclusion of each of those conditional statements. The conditional statement allows us to establish that if we have the given condition that there are 2 lines cut by a transversal, and this is the given condition for all of these postulates or theorems, we can then conclude, as a result of that 3 of these angle types happen to be congruent. The alternate exterior, the alternate interior, and the corresponding angles are respectively to each other congruent. However, with the consecutive interior or same side interior angles, we know that they are going to end up being, in this case, supplementary. So that's actually a little bit different of a conclusion. But I want you to pay attention to the order. Notice that in that particular set of postulates or theorems, we recognize that we are already given parallel lines. We are establishing that that is a given condition. What we desire to do is to prove lines parallel here. In order to do that, we are going to flip the script, if you will. We are going to reverse where the hypothesis goes and where the conclusion goes. So we're going to establish at the beginning of our converse theorems that this condition is provided and given, and we have to show that, and if we can show that occurs, we can then prove that the lines have to be parallel. And that is what the converses are going to do for us. So I'm going to show you the converses first, so you have an established understanding of their exact verbiage. If we look at the converse of the corresponding angle postulate, pay attention to what I've written on the screen, or what I've provided on the screen, and what you're now going to see. The converse says that if two coplanar lines intersected by a transversal and the corresponding angles are congruent, then the lines are parallel. Now, that verbiage is slightly different, but one of the things I'm going to single out more than anything is this. If we can establish that there are two lines that happen to be cut by a transversal, intersected by a transversal, and that the corresponding angles are congruent, then we can conclude that the lines are parallel. That is the reverse of what we just saw moments ago, right? So here we're establishing that we want to show that the corresponding angles are congruent, and then if they are, we can show then that the lines that are being cut by the transversal are parallel. So this condition here has to occur. We have to have two lines cut by a transversal. Now, for those that don't remember, coplanar means that they lie in the same plane, right? So coplanar means the same plane. Co being the same or together, and plane. The lines do have to be in the same plane. The reason for that is you could have two lines that never intersect but aren't in the same plane, and those are called skew lines, and we're not really looking at those here. So that's why they're using that adjective there, that modifier. So that being said, all of these converses are going to be worded in the same exact way. The hypothesis that you're going to see, if I go ahead and highlight that now, and I'm going to use, let's say, this color here, the hypothesis of each of these is going to end up being the same thing. The one thing that's different, however, is for the alternate interior angle theorem, it's now establishing this is the hypothesis as opposed to corresponding, and then of course we end with the same result, right? The lines are parallel. Or likewise over here, right, we have that two coplanar lines intersected by a transversal, and the alternate exterior angles are congruent, and then if that's shown, the lines are parallel. Or two coplanar lines are intersected by a transversal and the same side interior angles are supplementary, then the lines are parallel. So I bring that up because those are all conditional statements. These are actually the converses, however, of these statements, the ones that I have at the bottom of the screen. Now, the reason why they don't establish the words coplanar in there is because when they've already established that the lines are parallel, as they are saying right here, that automatically means they're in the same plane. That's why they don't have to reference that in the original postulate or theorem, because when you say that the lines are parallel, you are establishing that in fact you have coplanar lines, as these converses are establishing. So basically we're going in reverse. Now we're going to actually try to show that the angles are either congruent or supplementary, to then show that the lines have to be parallel. That is not what we were doing with the original postulates or theorems. So let's go ahead and take a look at an example. In this example, we are shown that we have the segments UW and VX, or XV, and the transversal highlighted in yellow VU. We can see that highlighted in blue are two angles which represent the same side interior angles, and their sum is equal to 185. The problem with this is that in order for the same side interior angles to be useful to us, we have to show that they are supplementary. Supplementary, as you know, means that the sum has to equal 180 degrees. And very clearly, that's not equal to 180 degrees. So that means that those same side interior angles are not supplementary, therefore the segments are not parallel, which is what this symbol here represents. That is the conclusion you can make definitively. Now, in the other case, we have the segments that are vertical here. So I've already highlighted using yellow, so I suppose I'll follow suit with WX, and that's fine. I'll do that. So here we have WX, and the line that's a transversal that they wish for us to focus on is UW, which is this line right here. So instead of focusing on 71 and 114, we're focusing on 114 and 66. However, their sum is 180. They're same side interior angles as well if you compare them to the transversal of UW. So they're both on the same side of that, and that UW is intersecting the two yellow segments that I've highlighted. That means that they are supplementary. This is good. That verifies that the lines are parallel, the segments are parallel. And the reason is because of the converse of the same side interior angle theorem. If you're proving that lines are parallel, if you're asked this question, you must use a converse to justify. You must not use the original conditional statements that I have at the bottom here. You're proving the lines are parallel. Anytime you're proving the lines are parallel, you are using these converses to do that, and we use the final converse there for that particular example. So now it's time for us to try an example of our own. Here we have angle 6 and 8, and they've told us that angle 6 and angle 8 are congruent to each other. So this is actually a given condition. So the condition here is that angle 6 and 8 are congruent. So you can kind of think of this as the hypothesis, if you will, because this is what we're trying to show. We want to show that the one of those angle pair relationships actually are in fact congruent or supplementary, right? So the first thing we want to address is what line is the transversal, and the reason we want to address that first is because we want to know what lines we are going to make the assertion are parallel. So line A is the transversal. In this case, this is what we're treating as a transversal. The question in your mind that you have to ask is, what two lines does line A intersect? Well, we know that line A intersects D and C. We had a problem in the last lesson that kind of outlined how to identify which lines a line that is a transversal intersects. Here's an example. D and C. So what we're going to do is we're going to assert that line D is parallel to line C. Now I'm going to put a little question mark next to that because we're asking ourselves that question, are they parallel? The answer to that question is yes. The reason why it's yes is because angle 6 and angle 8 are corresponding angles. They're corresponding angles, and we have that angle 6 is congruent to angle 8. So therefore we can say by the converse to the corresponding angle postulate, which I'm saying it out loud but I'm abbreviating this as CAP, corresponding angle postulate. So if I ever use that again, you'll recognize what I'm referring to. By that postulate, that converse of that postulate, the line D has to be parallel to the line C. Okay? That confirms why they are parallel, because the corresponding angles 6 and 8 are congruent to each other. That's the given condition, and that verifies it. There's a verifiable relationship between 6 and between 8. And so that is the goal here. Let's take a look at this example, angle 2 and 16. So we've got angle 2 and 16. Again, the transversal they belong to is C, right? So line C equals the transversal. I'm just going to write that because it's a nice short way of saying the same thing. It is a transversal. And the lines that we're going to compare are B and A. So I'll highlight those now in, let's do red. Those are the two lines that it intersects. So we can say the following. 2 and 16 are alternate exterior angles. Angle 2 and angle 16 are alternate, and I'm just abbreviating that, but that's alternate exterior angles. Angle 2 is congruent to angle 16. That's the given condition, right? That's what they're establishing as a fact for us, as the hypothesis for us So we can say that line B is parallel to line A since angle 2 is congruent to angle 16. So essentially, by the converse to the alternate exterior angle theorem. Okay, so that's me using the converse, actually using the converse as a justification for why they are parallel lines. Let's go ahead and take a look at this example. 3 and 14, they're congruent to each other. I identified the transversal. I identified that 3 and 14 actually are neither same side interior nor corresponding. They're both on the same side of the transversal, so they could never be considered alternate interior or exterior either. But in this case, 3 and 14 have no relationship whatsoever. There's no converse that describes their relationship. No parallel lines theorem that describes it. So therefore, we can't say if the lines are parallel. We have no converse available to use to justify that. So that's how I have to conclude that particular example. In this example here, I'm looking at the triangle XYZ, and I'm told that this angle ABX is 58 degrees, and this angle is 58 degrees. So the question is, are the lines, in this case segments, AB and ZY, parallel? Yes or no? Why or why not? So we're talking about this segment and this segment. Now, if you look at those two angles, I can assert that those two angles are corresponding angles. So therefore, I know, again, this is a corresponding angle postulate. This is the converse, rather, to that. So the converse of the corresponding angle postulate, sometimes referred to as CAP, right? The converse of the corresponding angle postulate guarantees that those two lines are parallel. Why? Because if both of those measures are equal to 58, we know that the measure of ABX is equal to the measure of angle Y, and that implies that the angle ABX is congruent to the angle Y. If they're equal in their measure, then they're also congruent to each other by the definition of congruence. And therefore, the converse of the corresponding angle postulate justifies what we're looking for in this case. So there's a demonstration of how I might use that converse to justify why those lines are parallel. In this case right here, we want to find the value of x. So here we have that the measure of angle 2 is this expression, and the measure of angle 8 is this expression. And we want to find the value of x so that we can make the lines A and B parallel, right? And A and B, of course, are cut by the transversal. So those are the lines we want to be parallel. So how do we make that happen? Well, first of all, we recognize that we have alternate exterior angles here, right? In order to show that the lines are parallel, we need alternate exterior angles to be congruent to each other, right? So that means we know angle 2 would have to be congruent to angle 8. That means that their measures are going to be equal to each other. We can substitute 6x plus 20 in for the measure of angle 2 and 8x minus 10 in for the measure of angle 8. And we can go ahead and subtract 6x first and foremost from both sides. And when we do that, we end up with 20 equal to 2x minus 10, where we can now add 10 to both sides. And again, here we end up with 30 equal to 2x, where we can finally divide both sides by 2. And we end up with our value for x. X is going to equal 15. So if we want those two lines to be parallel to each other, we need to make sure that x is 15. Otherwise, they would not be. In this example, I want to show that the lines P and R are parallel. However, I demonstrate that that isn't possible. The reason why is because 2 and 11, while we state that they are congruent, they belong to different transversals. We have two different transversals. That's a problem. There's no actual theorems, line theorems at all. There's no angle relationship between them that we can define that we've already described. So as a result, those lines cannot be justified as being parallel or otherwise. We just can't determine that. That's a really great way to describe it. Finally, in this last problem, we're trying to see whether or not the segments ED and AB can be considered parallel. Why or why not? The issue with this problem is that we have to say no, and the reason why we have to say no is because we have no angle measure information and without any angle measure information, we can't make a conclusion. Why? Because then we can't reference any of the converses to then justify why the segments would be parallel, the segments being here and here. Okay, for your exit ticket, you have your first problem here where you are tasked with determining which postulate can be used to determine that P is parallel to R. I would just give you the hint, by the way, that remember that we only use converses to determine whether lines are parallel or not. And so just take that with a grain of salt. Keep that in mind, if you will, as a little bit of a hint. On the second question, you want to find the value of x that makes the lines parallel. This is very similar to the previous slide or two that I just did. For example, I think it was this one, where I had to use alternate exterior angles, setting them equal, solving for the variable x, and solving and finding its value to verify that the lines are parallel. You're doing something very similar here. Please just remember to identify what type of angle pair angle 1 and angle 5 actually are, because that's going to help you determine how you write your equation to help solve for x. And then, of course, and this is the very last example that we did in the lesson today, where you have ED and you have these two segments you're trying to prove are parallel. And they are referencing for you this angle and this angle. They're giving you those angle measures. They're telling you what those angle measures actually are. And so my question to you is, given that angle information, does that make it possible then to show that they're parallel or otherwise not parallel? So that's going to represent lesson 5.02 over proving lines are parallel.